Alright, today's lesson is the last of our first unit, is we're looking at what an infinite geometric series is. So we already know that a geometric series is when we have a number that we multiply by and we're going to be adding. So if we went 2 times 3 would give us 6, times 3 would give us 18, and so on. So the only thing that's different now is there's no ending to it. We're just going to keep adding this on and on forever. So if we have a number like I just did, 2, 6, 18, and so on, it's getting bigger and bigger. We won't actually get a total sum. It's just going to go to infinity. But if we get smaller, so if we look at this one, that's this picture showing, we have a half, or a one whole square, then we cut it in half, then we cut it in a quarter, then we cut it in an eighth, cut it in a 16th, and so on. Because it's getting smaller and smaller, we actually get a total. We'll actually get a final number. Even though it gets smaller and smaller, those decimals get so small that they really don't affect the total. So what we first have to figure out is, does it get bigger or does it get smaller? So if we look at this first example, 4 times 3 is 12, times 3 is 36, times 3 is 108. So this is going to continue to get bigger and bigger. If we look at the next one, we go from negative 2 to 4, to negative 8, to positive 16, to negative 32. It's still getting bigger and bigger, even though it's going positive, negative, those numbers still get bigger and bigger. So what that means is there won't be a final sum. It'll just basically approach infinity for both. So whether it's positive infinity, negative infinity, it makes no difference. They're going to continue to increase and we won't get a final answer. So if they do that, if the numbers get larger and larger, we call those a divergent sequence or a divergent series. It just keeps getting bigger and bigger. Doesn't do too much for us. But if our numbers get smaller, so if we go from 270, divide by 3, we get 90, divide by 3, we get 30, and so on, this is going to get smaller and smaller. Eventually, we'll get such a small decimal that it's not going to do anything. And it doesn't matter, again, if we go positive, negative. If the numbers are getting smaller and smaller, they will actually have some sort of final sum. So for both of these, we would get a final answer. Because they get smaller and those numbers get closer and closer to 0, we will get a final answer, and we call these ones convergent. So convergent is get smaller, and that's the good ones. Divergent, they get bigger, which means they're not going to work. So if they're convergent, and this formula only works for convergent, then we can actually calculate the sum pretty easily. So we write it as S infinity. It's just to show that it's an infinite sum. We need term 1 and we need our ratio, and that's it. So remember, this only works for convergent. And so if our R number is less than 1, which means half, a third, or so on. So you can see here the way this is written, this would be a number like a half, or it could be negative, like negative a third. So if it's smaller than 1, that means we're getting smaller, then it's going to be convergent. If our R value is bigger than 1, 2, 3, 4, or negative, we get divergent, and we don't want to use the formula. So it has to be less than 1, or getting smaller. So our formula was term 1 over 1 minus R. And so it's a pretty easy formula, so we just have to figure out if it's convergent or divergent. So first thing, we're getting smaller and smaller and smaller, so that's convergent, so that's good. We can use our formula. So just put in term 1 is 27, and 1 minus R, our R is we're dividing by negative 3. So our final answer in this case should be just 27 divided by 4, which gives us 6.75. And if you're not sure, you could actually try this. So if we go on our calculator, just put in 27 minus 9 plus 3 minus 1 plus, we're divided by 3, so it'll be plus a third. And then we're going to minus a ninth. And I messed up again. We're dividing by 3, so it should have been 1/3, not 3. So 1 minus negative a third would actually have been 1 1/3, or 4/3. So if we go 27 divided by 4/3, we get 20.25. Okay, so now what we were doing before, if we go 27 minus 9 plus 3 minus 1 and add a third, and then we have minus a ninth, and so on, we're getting an answer right around 20. And so if we keep on going, you can see it's not going to change that much as that fraction gets smaller and smaller. So 20.25 is the correct answer. So this next one we got, so yeah, just be careful, our R was negative 1/3, so we have to make sure we put that in the formula. Okay, so our last thing we've got here is 4 minus 8 plus 16, so our R value in this case is negative 2, but because it's bigger than 1, we would say it's divergent, so we can't find the sum in that case. The sum would be just infinity or negative infinity or something like that. Okay, so let's look at a couple more. So here we have a half, a quarter, an eighth. So it is getting smaller. Our R value is 1/2. We're timesing it by half each time. So our infinite sum is going to be term 1, which is a half, and 1 minus a half. So if we actually do this, we have a half divided by half, which is just 1. So this is kind of like our title page. Let's go back to it. If we see we had one piece of paper, and if we divide it into half, a quarter, 1/8, and so on. So if we add all those up, you can still see it still adds up to one big piece of paper. And that's kind of what we're getting with that one. Okay, so that one was convergent because our R is a half, so we could do it. Then that last one here, you can see our R value is 2. We're timesing by 2 each time, so we'd say that one's divergent, which means we can't find the sum. And that's all for infinite sums. Pretty easy topic.